Hello, Raymond. Well, thank you for the opportunity to participate in the Scale and Biochar Forum. I'm going to be presenting our company, Arty, and why we emphasize in the manufacturing of modular pyrolysis systems. All right. So, by the end of the presentation, I hope you have a better idea of what we do. And these are the systems that we promote, that we manufacture, and that we have designed all these years in the biochar industry. So if we do a closer look of all the components, it's their modules. All of them, their modules can be interchanged, removed, put, improve, whatever. So the idea is that all this is modular. We can assemble it anywhere, and it takes a few hours to put it together, bring it down from a truck, and put it to run. So we have a walking floor trailer, goes to a bin, then a grinder. Well, depending on what system we need, but basically most of the materials that we process, we try to bring it down to an inch or somewhere around there. So most of the material needs to be ground. A dryer, most of the inexpensive biomass comes wet, so we need to bring it down the moisture from 40% to 25 and then run it through our reactor. That's this system, what it's capable of. Then we have our pyrolysis system, and then we have a transfer auger, and then cooling system, or we use water and nutrients in some cases. Depends on what is the product that we need to do. But this, in a nutshell, this is what we do. We have been improving this system, making more efficient, making more cost effective, making it higher throughput, and most importantly, being able to tweak the process in order to tweak the product and the characteristics of the biochar. All right, so this is the group. We started in 2013. We're a group of Iowa State students, and we work with thermochemical conversions in various areas, mostly by oil. All right, so we started the company after a trip to Nicaragua. We did a grant. We did a project there from money that came from a grant from Europe. Great experience. We produced biochar, and we showed how easy it is to sequester CO2 and improve the soils. We didn't measure improvement, but we measure CO2 sequestration. All right, why we are focusing into modular systems, I'll show you in a minute. Most of them is due to the economics of the systems, right? Biomass is very light, it has a lot of moisture. So in general, moving this is a little bit complicated, and most of the biomass are, distributed. So having a system like this that we can bring biomass into piles, into satellite areas, like what we like to call, then processing makes a lot more economic sense. Okay, but all this analysis, obviously, it depends on a client basis. But mostly, if you're talking about a couple of thousand tons of biomass production, well, in general, those ones will require mostly modular systems, to make ends meet in terms of economics. So this is, for example, a facility, this Iowa State facility, but it's just to give an example of, in this situation for these clients, when we do economic analysis, we show them that with the modularity of these systems, they can save significant amount on a biochar basis. In this case, $150 per ton. Why? Because you start looking into the handling, into the transportation, into all the equipment that you need. Well, sometimes it's a lot easier just bring the reactor and put it there and making it work. Our system works with very little power. We work with a generator if it needs, but we save a lot of cost. In many cases, all the handling system, like dozer and trucks and all the stuff, sometimes it's even more expensive than the whole system that we're trying to implement in many cases, right? So that's one of the issues. And for example, in this system, for this client in this situation, obviously it all depends, but we would save $50 to $200 per ton in biochar when we bring the processing facility to the site. Okay, same thing, transportation and such. What we have emphasized in pyrolysis, by the way, we work in before in gasification, fast, slow pyrolysis, carbonizations. We have done some work on those areas. Why we focus in pyrolysis? Because of the product. Okay, as you guys know, biochar could be very heterogeneous depending on the feedstock that you use and the processing conditions. So with pyrolysis, we can make the biochar we want in broader terms, but it gives us more opportunities to tweak the product. Okay, this is just an example from Johannes Lehmann, and just to show how the temperature, it changes the properties of the biochar. And in many of the systems, for example, let's say, well, here I don't have combustion, but some of the biochar is done with incomplete combustion system, which is difficult to control, and therefore the properties very difficult to control. Well, it's very hard to get this right, and see what the 100 degrees Celsius difference make in this example, for example, right? And these are examples of different biochars, and this is an example of carbonization. You know how biochar or how charcoal that in some situations can meet the biochar standards, in many situations can. Well, this is the legacy of how it has been done in many places and still being done. So these are the systems that we want to get out, find different alternatives and better. There's an example from a researcher from Iowa State, excellent researcher, Dr. David Laird. And the same idea is, in this situation, the transcendental changes in the soil due to this type of biochar. But how much different would have been if they would have used a different biochar, right? So in this example here below, we can see this is a meta-analysis from Jeffrey, another researcher, and how it changes and changes the response of the biochar that you're using in the yield of that material. And it's the same idea: is, well, different biochars in different situations get different responses, right? So how important is to know what you're doing precisely. So we'd like to say we don't sell biochar, we sell specific biochar or design biochars. And in general, we if you want to have any details on the client and the situation, well, we'll do something general that it will be useful in any case. But if it cannot be like that, well, if we have more specifications of how it's going to be used, the deficiencies in that system, we can tweak many things in the biochar production. And from an agronomy side of things, is like similar to the fertilizers. You don't use one type of fertilizers for every situation. It's just the opposite. You do analysis, you understand the situation, and then you do the recommendation. On the biochar, the same thing. Do you want to, for example, you want to change the pH? Do you want to change the water, the infiltration, for example? If you want to change the structure of the soil, the cation exchange capacity. Maybe the salinity is a concern, and you want to start absorbing more cations into the biochar. Well, there are tons of things that you can modify depending on the biochar that you're making. So you need to know everything. You need to know the biochar. You need to know the conditions, the plants that you're going to be using, the soil, and all those things. Gives you a better idea of what would be the best biochar for that situation. And there's huge differences, right? Biochar in the market, there are plenty. And these are general biochars, which they're going to be good in most situations, absolutely. And what I like to mention or make it clear is, if we know the situation and we use the right biochar, you should always see improvements in the soil and in the yields and in the soil health for sure, and the carbon sequestration, absolutely. Okay. With Arty, we do many products. The ones that you can buy online, those are general products, but we do designed biochar. And those ones are with relationships with clients. We develop the products and we sell them. All right, why we work on the systems? I will explain you why for us the system is more important than make biochar. Sometimes you cannot make biochar because the other parts of your equipment is not there, right? And that part is a lot more expensive, maybe that the pyrolysis system that you're going to put, or what equipment you're using for making the biochar. So these are examples. Low-tech paralyzers, they're hard to control emissions, hard to control the material that you're making. Great for third world countries, absolutely, but in many cases we can move away from those, and that's what we're trying to do. The legacy of carbonization, and the smoke and some other things. These examples of a TPI kiln, and also the typical holes that we make, and then we bury them and we cover them with dirt. And well, anyway, long story short, you make very little material for the amount of work and material that you're using, and the control of the process is a little challenging. In the industrial world, there are paralyzers. These are older pictures, but there are many paralyzers or gasification systems. But again, they're extremely expensive. And when you start scaling up, the amount of biomass that you need is very significant, and then the economics of moving that biomass is very challenging too. So in other words, the capital and operational cost that you need to invest to make that biochar is very significant, and your prices are significant as well. And the mobile units, great, but the same challenges like in the previous one. Well, in the low tech, well, sometimes it's very hard to control the systems, and therefore the biochar. In many cases, you need a dryer or you need a grinder. It's just a small unit, and there's a lot more than that in the biochar manufacturing. So when we decided to start making equipment, we saw the challenges that it's not just the pyrolysis system, but everything else. We need to make it simple and effective so we can run it 24/7 and make biochar, industrially and meet those properties that we want to meet. So here is our examples. These are dryers. We use the same heat that is produced in the pyrolysis reactor. The waste of that is being used in the dryers. So we don't have any propane or anything else. It's just waste heat that we're using. And in many cases, some other clients that we review, they have dryers, for example, and those dryers are as expensive as the pyrolyzers, and they use as much as energy as the pyrolyzers. I mean, a lot more energy, but long story short, it's a very hefty component on the system to make it economical. So these are pyrolyzers. Here on the left, we have one train, and then how we scale up, we put many trains. So the material comes from the back to the front here. It's being cooked, and as it cooks, the gases comes out of those pyrolysis train, we call them, and in this box, they're combusted right outside. So that's the heat that it provides for the material to be processed. And by the end, it's carbonized and it gets out. So they're very simple. All of them are very simple. The dryers is a heat exchanger. The cooling towers are heat exchangers. And well, these are super sack holders and all the other equipment that you need. Another thing is making biochar is the first thing, but you need to make biochar products. And we also make, for example, these are pulverizers, so we can turn this biochar, like in our products, liquid biochar, which is a very fine material. But also in the industrial world, they use very fine powders, like the carbon black or the powder activity carbon. All those are very fine. So the biochar is one thing, but then the application of the biochar or the mixture into other products is also a challenge. So we work with clients to develop those. Again, more examples of different equipment that we make in order to make the system more cost effective. And these are some laboratory equipment that we make, and also some more entrepreneur pyrolyzers for people that want to do biochar on their own. But basically what we do is our systems, we put everything in a shipping container so we can move them around. We can go and plug it to a 30 amp plug, 240, single phase if we need. We make 3-phase, but we can do also single phase. And what is the idea? Is that it's very simple. You bring it down from a truck, you connect it to electricity. We have small propane tanks, 20 pounds, the ones I use for grilling, and you start the equipment. In 1 hour, you're making char. That's the most important for us. That's how we can bring down the cost and make our products more competitive to establish carbon products, like activity carbon, for example, right? The activated carbon is the carbon has been activated afterwards, but the first part, the carbonization, it can be done in this situation. So there are many things that this kind of industrial equipment assist in the economics and the feasibility of the overall system. This is some equipment that we have in different parts of the world. And again, some of them are stainless, some of them are a little bigger than others. But basically they're modular system, auger-based, and they're easy to run, easy to maintain, easy to troubleshoot and replace. They're modules, right? All right, and what else? This is the group here. My colleagues, this is our first machine that we installed. So yeah, if you have any questions, so don't hesitate to email us or call us, and we will be happy to help you in any biochar related project. Thank you.